Good afternoon. This is an attempt to explain what I'm calling my super spin indexer, because it's like a spin indexer but on steroids. If you look at a spin indexer, you get a plate that's divided normally into 36 divisions, and then a fixed set of holes in a backing plate which has got 10 divisions. That gives you a total of 10 by 36, 360 degrees. Right, how that works is like this. (360 degrees over 360 degrees is 1 degree per division. That's what we're looking for. And some bright spark notice that 36 times 10 is 360. So by having 36 division plate and then 10 offsets, you can create 360 divisions in a very compact format. Now, to calculate the size of the divisions for the offset, well, first let's deal with the main plate, which is easy. It's 360 over 36, 10 degrees per division. For the offset, which is the back plate divisions, the fixed plate divisions, you just take your 360 over 360, 1 degree off the 10 degrees, so you get 9 degree. So on a normal spindexer, the back plates holes are 9 degrees apart, and the main plate, the moving plate, are 10 degrees apart, one degree difference. So what happens when you're on 0, 0? And everything's on 0. We're on 0. And then if we move to 1. Now I've got an extra plate here, but I'll explain that. All that is, I'm staying on 0, is a counter so that I can easily match up where I am. I can read it like a clock. So if I go round to 1, you notice that in this case I've advanced the 0 mark to 3.75 degrees, because this is 96 divisions. If I go round to 2, I've now advanced 7.5 degrees. If I go round to 4, I've advanced 15 degrees, and so on. So advanced to 5, I'm back at 0, 22.5 degrees. So on a normal spin indexer, you're going 10 minus 1, 9 degrees off the 10, which gives you 1 degree, so you're advancing 1 degree at a time. So you have a main movable plate, 36 10 degree divisions, and a moving offset plate of 10 9 degree divisions. Right, on my spin indexer, I wanted to be able to change those plates to give me other divisions, because 360 degrees is great if you want something that is divisible into 360 degrees. But let's say I wanted 96 degrees, which is common for gem cutting. My 360 over 96 gives me 3.75 degrees per division. Now 96 is 16 times 6, so I can have a 16 division moving plate and a 6 division fixed plate, and 360 over 16, which is going to be the angle for the moving plate, is 22 degrees, and that's for every 6 divisions. 22 is 3.75 times 6. two ways to get to the same answer. Right, the fixed plate divisions are 22 minus the 375, 3.75, 18.25 degrees. So I need, which is this plate here, these set of plates here, a main plate with 16 22 degree divisions and an offset plate with 6 18.25 degree divisions, which is exactly what I've got here. My little knob at the front, getting the mechanics of all this right was a nightmare. There's two bearings in here for the spindle to rotate. Let me just take that out. For the spindle to rotate freely, there are two bearings at either end of this. There is a collar which the moving plate attaches the moving plate to the spindle. This counter plate needs to be rotate freely of the spindle and the fixed plate, the moving plate. So there's a thrust bearing and a collar that which the moving plate is screwed to. The collar is attached to the spindle with a set screw inside here, and then there's a thrust bearing in there to allow this to move freely. And all that is say I'm at 6, oh, use the right pin. Say I'm at 6, I'm in. That just gives me where my divisions have to line up, so 4 lining up with the 4 on the fixed plate. Is that marked there? So that gives me 12 plus 4, for example, and so on. Anyway, you read it like a clock, more or less. 6 and 4 is 10. Yeah, that's it. 6 and 4 is 10. So it just easy way to keep track of your divisions, which is why I went to the length of having this. In the final version, I will have a smaller plate. This will be split into 2, and the smaller plate will be screwed to a permanent knob on the inside. Much easier to make. I appreciate that this is harder to make than a spin indexer, because for every indexing plate you need a fixed plate, a moving plate, and a pointer plate, if you like. I will also be making 120 divisions, so 120, 360 over 120 gives me 3 degrees per division. Now 120 is 24 times 5, so with a 24 moving plate, 24 hole moving plate and a 5 hole fixed plate, I can get my 120 divisions. Now, 360 divided by 24 is 15 degrees per division on the moving plate, and 15 minus 3 is 12 degrees, which is the offset per division on the fixed plate. So we get a main plate with 24 15 degree divisions and a fixed plate with 5 12 degree divisions. So I can have 3 plates and very small format with a lot of variety. Okie doke, I hope that explains something. Thanks.